Hello and welcome to this on-demand event today. My name is John. I'm here from UniTasterDays and I'm really looking forward to this conversation. I always cover different subjects and today the subject I'm going to be covering is applied artificial intelligence, which I've got a massive interest in. So I'm going to learn a lot from this. I'm joined today by Hassan. Hassan is a professor of visual computing at the University of Bradford and he is our resident expert and is going to tell us all about it. But Hassan, can I come to you first, please, and just find out a little bit more about yourself?
Yes, John, thank you very much. So my name is Hassan Yugel. I'm a professor of visual computing. I'm also the director for Center for Visual Computing at University of Bradford. So I've been working in the area of computer vision, visual computing, and more recently, artificial intelligence for a number of years. And I'm interested in actually learning more about the world through visuals, but also utilizing computer algorithms and data.
Thank you. And it's very much seems to be very much where it's at in terms of artificial intelligence at the moment. So first question is just to find out, why should students essentially consider artificial intelligence and in your case, applied artificial intelligence?
Yeah, so I'm sure, John, you're aware that artificial intelligence, that keyword, that phrase is everywhere. You know, we open a newspaper, we hear, radio, or wherever you go, it's all about artificial intelligence. So, and for the right reasons. So if you think about how the world kind of generally works, we are increasingly adding automation to various processes. So if you think about like long time ago farming, we start bringing machinery and so on. So artificial intelligence, one of those new technologies that is going to add another layer of automation to everything that we do, from business analytics to agriculture to manufacturing to computer gaming. Everything that we do, we're going to add a layer of automation. So with this new technology, we're going to bring in new things. So that's why I think artificial intelligence is so important. That's why we should all study an element, an aspect of artificial intelligence, in my view.
If a student studies applied artificial intelligence, can you just give me like a snapshot of what they can expect on the course?
Yeah, so we talk about not just artificial intelligence here, we talk about applied artificial intelligence. Now, general artificial intelligence, you will learn quite a lot about computer algorithms and mathematics and statistics. But in the case of applied artificial intelligence, you are taking real problems, you're trying to solve real problems through artificial intelligence. Now, the important thing about we need to bear in mind is when it comes to artificial intelligence, you need two things. One is algorithms or methods that the computer be used for to teach the computer. So these are what we call algorithms. The second part is what we call data. So we need a lot of data to actually teach the machine so that it can learn patterns and it can behave the way we want it to behave. So we need actually these two things together. With applied artificial intelligence, what we're doing is we're taking real data sets. So let's say you might be interested in solving a problem related to healthcare, maybe a diagnosis of cancer, maybe analyzing some genes or whatever. And what you want to do is you want to get that data set and you want to teach the machine patterns in this data set so the machine can actually make predictions. So with applied artificial intelligence, you're taking real life problems. It may come from business analytics, it may come from manufacturing, it may come from gaming. You are trying to actually add that automation layer. So what you'd want to do is you want to take data sets, you want to train the machine. And a good example these days is the ChatGPT. What ChatGPT has done is taken the entire data set available on the internet and trained a very large algorithm to actually predict. Essentially what it is doing is predicting the next word, and then it strings words together, makes a coherent sentence. So very much like this, what applied artificial intelligence would do is try and identify real problems and then solve it through data and through algorithms.
What a brilliant answer that was. I was actually going to ask you what the difference was between artificial intelligence and applied, but you've covered that. And
yeah,
also using the example of ChatGPT, which I think everyone watching this will have used at some point, and I use on a daily basis. And
absolutely,
it makes sense, doesn't it? It kind of pulls data and goes from there. Right. So what I want to do now, Hassan, if it's okay, is kind of get a glimpse into almost like the future of this, because I know you're famous for your research. You're very active when it comes to research. So do you mind giving me a kind of an introduction in terms of what might be on the horizon, or at least what you're working on?
So in terms of research, I think there's a lot of research that's actually going in the area of artificial intelligence. As I said before, I think what's happened over the last 10, 15 years is we have amassed quite a lot of data. We have the internet, we have the social media, everybody's connected. So we're just feeding streams and streams of data. It may be to do with imagery, it may be to do with our conversation, our chat around, and so all this data is actually getting fed, and then algorithms are being utilized to actually understand this for various things. So for example, in my own research, we are looking at things like in healthcare, we're looking at organ transplant. So the way we are looking at organ transplant is we actually teach a machine a set of organs, maybe it's a liver, maybe it's a kidney. We show this to the computer, and the computer learns about the shape, the colors of these organs. And then based on that, it can make a prediction whether this organ is good enough to transplant or not. And we're working with surgeons to identify the best organs and give this data to the computer to learn. That's just one example. Another very interesting example is like we are looking at artwork, for example, Renaissance artwork like Raphael, 500 years ago, they painted these paintings. And questions comes as, did they actually paint these paintings, or was this a workshop painting? Who collaborated with these people? Now, looking at these paintings and feeding the data to the computer can actually look at in very great detail the colors, the tonal values, the hues, and even down to the brush strokes. And then by analyzing this, you can actually learn quite a lot about what's happened like 500 years ago. Now, again, what is actually important here is the elements that we are using, the data that we're using in detail, and the algorithms that we're using to actually make these kind of decisions. So if you think about it, in what's in the horizon is, I know we all talk about, when it comes to artificial intelligence, everybody's thinks about is ChatGPT. Yes, ChatGPT is good for artificial intelligence. It is one of those things that actually brought the artificial intelligence to the forefront, but it's not just ChatGPT. ChatGPT is what we call generative AI. So what it does is actually takes data and it generates new stuff. So like sentences, paragraphs, essays, and so on. In the case of image generation tools, it takes loads of images and then it generates new images. This is what we call generative AI. Now, there's an element of generative AI that will be very useful in things like entertainment, gaming, and so on, even writing essays and writing code. For example, I use ChatGPT almost every day to write code for me. The code I used to write for a week, it can write within a matter of seconds. So it helps with my work. It doesn't mean it can replace me as a programmer. It just helps me. It's like a calculator. If I can do mathematics, I can do addition either through or multiplication through just, physically, or I can use a calculator. So it just helps me to do that. So that's one aspect of what we call artificial intelligence, which is generative AI. Now, there's another aspect which we call predictive AI. So for example, I take a bunch of organs, liver or kidney, and then teach the machine, this is what a good liver looks like, this is what a good kidney looks like. Now then I show a new image to it and say, can you predict what's the possibility of this image, this liver or this kidney being good? So this is what we call predictive AI. So there's a lot of work, there's a lot of interesting things and a lot of benefit actually using these two. So I think it's important for us to kind of think about that it's not just ChatGPT, but there is this generative AI and the predictive AI. And all the problems that we come across will have a mixture of this. But I think we need to give a lot of credit also to the predictive AI, which is going to play a big role in artificial intelligence in the next coming years.
Having heard that answer then, it just blows my mind. Like artificial intelligence and applied artificial intelligence just blows my mind. And you're in it day in, day out. Does it blow yours as well, or you?
It does, yeah. So for example, we every single day we are uncovering some really, really exciting stuff and very interesting things. So I mean, one of the key things that I'm doing at the moment are this AI and art analysis. And every day when I look at a certain painting, I see some new things. So for example, we are discovering things that you wouldn't have really thought about. I mean, on the last this week, we've just discovered a painting which is an autograph. It's autograph Raphael painting. Now I'm beginning to question whether actually Raphael painted the painting, because looking at the data, you're comparing autograph Raphaels with this painting, and you're seeing very, very different things. You're looking at the brush strokes of this, the brush stroke patterns, you look at the color palette, and it's not matching. So usually, if you're an artist, if you paint a certain painting, there is a very narrow band of data that are available that you can look at. For example, your color spectrum. I mean, we know when we look at a Van Gogh, for example, it has got a certain brush stroke, a certain color spectrum, and certain tonal values. And if it differs, we know, even physically looking at. But these machines, these algorithms, imagine this. You are looking at a three-dimensional world in 3 dimensions. The computer with our algorithms, it can look at around 4,000 dimensions. So, and it can look at an image in about 4,000 dimensions. So it can look at the color in hundreds of dimensions, the texture in hundreds of dimensions, the brushstroke and so on. So you see these algorithms are looking at something in a very great detail that we can't even imagine. Some of these things I can't even physically explain what it's looking at. It's looking at certain statistics, certain parameters, and so on. So the point I'm trying to make is actually this is a tool that can help us to make good judgments, because we can't just rely on our eye to make judgments. That's why we invented things like microscopes and scanners and so on. So just like that, I think AI is a tool that can provide lots of data and then do this kind of analysis.
I find it absolutely fascinating. So
Excellent.
no doubt there'll be a lot of students, whether that's directly on the platform or with their school groups, watching this thinking, good grief, this sounds so interesting. So if kind of a student thinks, I want to do this course, I want to apply to it, do you have any kind of application tips or things you'd like to see in a student as far as kind of the next stage of their journey?
Yeah, so for example, I think it's important because, as I said, this is applied artificial intelligence. So we are thinking about real world problems. We're trying to solve real world problems, whichever direction it comes from. It could be archaeology, it can be manufacturing, it can be computer gaming, it can be entertainment. So what we usually, I mean, in a course like this, you're just not looking for theory. You can be a computer programmer, you can actually sit behind a computer and code. That's one thing. But we are looking also for people who got their mindset on applied problems. So I think anything that you've done applying, your portfolio work or your other work that's related to kind of problem solving, because this is all about problem solving, using a piece of technology that already exists and then taking that and taking data sets and solving problems. So any aspects of your work, your interest in problem solving or any portfolio work will actually help a lot. It's not just about getting the highest grade. Yes, grades are very important, but at the same time, you need to have a mindset of actually saying, actually, this is a very good problem. I want to work on this problem. So I want to solve this problem. Let me get together the data, let me get the available information, and let me create a machine learning model or an AI piece to actually solve the problem. So I think anything that actually in your portfolio that helps, that says, actually, I've got involved. Now, it may be that you are involved in I don't know, in some other activities that are completely unrelated, but that actually might have some problem solving aspects to it. So I think putting those aspects in the application will be very useful as well, I think.
And my final question, which is going to be a tough one to answer because this is such a fast moving area, but is to pick your brains as far as careers. So a student is on the course, completes the course. Can you give us a snapshot on what they might do after finishing it?
I think there would be a wide variety of career. I mean, it's very difficult to predict what in 10 years, the space of AI is going to look like. But what I can say is actually technology will be around us. We will use technology. So AI is a great piece of technology. And what we learn through is applying technology, understanding how to solve problems. So anybody with a degree like this will have the knowledge of artificial intelligence, mathematics, statistics, how to apply this to real world problem solving. They'll have practical aspects for how to solve problems. So essentially, I would say you can go to kind of any area. Now, it may be that you might want to be, you're interested in actually doing coding, sitting behind a computer and doing coding in using artificial intelligence, or you want to sit in front of a boardroom and explain your findings through analytics using graphs and so on. So there's a wide variety of career options, I think, from this. It's difficult to say, oh, you're going to be a programmer or you're going to be doing data analytics. Actually, these are also embedded within this kind of a program like this. So I think there's a wide variety of things you could do. So you also, in a program like this, a course like this, you're also learning quite a lot of soft skills. For example, one thing that you would, I suspect, would learn is things like how to present, your data to people who do not understand AI, for example. And that's a skill in itself. So I think you will learn quite a lot of those kind of soft skills, which are actually very important in an area like this.
I've loved this conversation. The sign of a good on-demand video is how many times I check I've pressed the record button, and I've done that.
Oh, is it? Okay.
The final thing for me to do, Hassan, is just to say a huge thank you to Professor Hassan Ugal joining us from the University of Bradford for this applied artificial intelligence introduction. Hassan, huge thanks. Really appreciate it.
Pleasure, John. Thank you. Thank you.